This video here is a nice and interesting problem. Here is the following setup. Find p of x if we have this condition. We have x minus 2 or 3 is multiplied by p of x plus number 7 equals x is multiplied by p of x. Okay? If you take a look at the both sides of this equation, we have p of x, we have the function is repeated 2 times. We have p of x plus number 7. The other side of this equation, we have p of x is multiplied by x. Okay? What's the fact we are going to base on to solve this equation? So if you take a look at 2 or 3 and number 7, we have relevant information between the left and the right hand side of this equation, especially 2 or 3. There is kind of a relationship between number 7 and 2 or 3. So if you check 2 or 3 is the same as 7 is multiplied by 29. Okay, so I'm going to use this fact here in order to solve this equation. First of all, if I'm going to plug x with number 0 here, I get this function, the right hand side of this equation, 0. Okay, so let's do that. If x equals 0, I get here 0, I get minus 2 or 3 is multiplied by p of 7 equals 0. So since O3 is different than 0, so which means p of 7 equals 0. Okay, this is nice thing here. So this is one side. The other side, if I'm going to plug x with 2 or 3 here, I get 0 here as well. Okay, so let's set if x equals 2 or 3, I get 0 here. I get 0 for the left hand side of this equation. I get 2 or 3 is multiplied by p of 2 or 3, which equals 0. Since 2 or 3 is different than 0, which means p of 3 equals 0. Okay, so if we, as we determined before, we know 2 or 3 equals 7 is multiplied by 29. Okay, so which means 2 or 3 is a multiple of 7, and we found p of 7 equals 0, which means p of 1 is multiplied by 7 equals 0. Also, we found this one, p of 3, which is p of 7 is multiplied by 29 equals 0. It seems this one is going to be on this form. So everything which has a multiple of 7 is going to be 0. Let's check, for example, if I'm going to multiply here, 2 is multiplied by 7. Let's check p of 14. So of 2 is multiplied by 7, which is 14. Okay, I'm going to leave this box here empty in order to get this term p of 14. I'm simply going to add 7 here. Okay, I'm going to plug x with number 7. I get 7 minus 2 or 3. So we don't have to calculate this one. This one is given as 7 plus 7, which is 14, is the same as 2 is multiplied by 7 equals 7 is multiplied by p of 7. Okay, we already know p of 7 equals 0. Okay, since this term different than 0, which means this one must be 0. Okay, this one is telling us p of 2 is multiplied by 7 equals 0. We found p is multiplied by 1, 7 equals 0, and also we found p of 2 is multiplied by 7 equals 0. Finally, we found the big number, which is multiple of 7 is also was 0. Okay, it seems this one is going to be written on this form all the way down. Okay, let's prove this one inductively using the induction proof. We already found n equals 1, which means p is multiplied by 1 is multiplied by 7 equals 0. So let's suppose by induction p of n is multiplied by 7 equals 0. Okay, by induction hypothesis. Let's prove p of n plus number 1 is multiplied by 7 equals 0. This is our goal. If we prove this one, the whole thing is done. Okay, so let's choose n between number 1 and 28. Why I have chosen n between number 1 and 28, not including 29? We will see that at the end of the proof So let's set x equals 7n. Okay, so I'm going to take this value of x and insert it back into the original equation to see what the expression is. So x is going to be replaced with 7n minus 203 is the same as 7 is multiplied by 29. Okay, is multiplied by p. X will be replaced with 7n plus number 7 equals x, which is 7n, is multiplied by p of 7n. Okay, by assumption we have assumed this one equals to 0. Okay, which means the left hand side of this equation must be 0. But this term, if I'm going to take number 7 as a common multiplier, I get n minus 29. As we said here, n is between number 1 and 28, not 29. If n was 29, you get 0 here. You will have a problem. We cannot say this one equal to 0. This is the reason why I have chosen this interval, not included 29. If this one is not included 29, which means this one is different than 0. If this one is different than 0, which means this one must be equal to 0. If I'm going to take number 7 as a common multiplier, I get 7 is multiplied by n plus number 1 equals 0. So I have proven this one. Finally, of 7n equals 0. Okay, I'm going to use this fact for the next step. Let's erase this board and move on. So previously we found p of 7 equals 0, and we found p of 2 is multiplied by 7 equals 0. Inductively, all the way down, we found p is multiplied by 7n equals 0. If I'm going to interpret this one, for n is between number 1 and 29. Okay, what's the most important thing we can extract from this fact? This one is telling us, since we have p of 7 equals 0, p of 2 is multiplied by 7 equals 0, and all the way down until you get p of 7 is multiplied by n, with n is between 1 and 29, is telling us 7, and this is telling us this number 7 and 2 is multiplied by 7, and all the way down to 7n are the roots for this polynomial. Okay, if I'm going to express that, you will have the following expression. You will have p of x equals x minus 7 is multiplied by x minus 2 is multiplied by 7 is multiplied by x minus 3 is multiplied by 7, and all the way down to the x minus 29 is multiplied by 7 is multiplied by another function. Let's call it q of x. Okay, now p of x is expressed as this form. Okay, so the question, why this form is written on the form of this product is multiplied by this function? Why you have added this function here? Because sometimes you get a function, we don't know about it. We don't know what's the multiplicative function was multiplied by this product. If sometimes you get a function is multiplied by this whole bunch of these products, sometimes you get sometimes this function, it could be a function itself, but is not containing any roots. The only root that we have, this one, or this function, it could be a constant. Okay, now our question, we are going to determine this one, q of x, because we know p of x, we know all this term, we need only this one, we need to know this one. Okay, how to determine this one? I'm going to use the same function. If you take a look again at the origin function here, we have p of x plus number 7. We have p of x. I'm going to just add number 7 here in order to get the same form. So by adding that, I get p of x plus number 7. If I'm adding 7 here, I get x here. If I'm adding 7 here, I get x minus 7. If I'm adding 7 here, I get x minus 2 is multiplied by 7. And all the way down to the x. If I'm adding 7 here, I get minus 28 is multiplied by 7. Is multiplied by q of x plus number 7. Then we need to multiply this one by x minus 2 or 3 in order to get the right hand side of this equation. in order to have this equality. Okay, so this term is going to multiply it by x minus 2 over 3. I will have the same thing here. This one is going to be multiplied by x minus 2 over 3. The whole product equals the right hand side of this equation. So the right hand side of this equation is a x is multiplied by p of x, which is x. I'm going to replace p of x with this found expression that we have before, which is going to be x minus 7 is multiplied by x minus 2 is multiplied by 7 is multiplied by x minus 3 is multiplied by 7, and all the way down to the x minus 29 is multiplied by 7 is multiplied by q of x. Okay, then now we'll have a lot of stuff are going to be cancelled out. So I get here x is going to be cancelled out with this x. I get my x minus 7 will be cancelled out with x minus 7. This one will be cancelled with this one. This one will be cancelled with this one after this one. And all the way down, this one is going to be cancelled out with the one before this one. I will be left with this one. This one also is going to be cancelled out with this one, because 2 over 3 equals 7 is multiplied by 29. Okay, which means this one also is going to be cancelled out with this one. I will be left only this one equals to this one. I will be left with q of x plus number 7 equals q of x. When you see the things like this, we have a function, you add in the terms is not changing, you have the same thing here, which means this one is a constant. So I'm going to replace with this q with c as a constant. Okay, finally we found p of x. Finally we found p of x equals constant c is multiplied by a product from as I goes from 1 to the 29, okay, of x minus 7 is multiplied by I. Okay, like this. So I have undo this video. By the way, don't forget to hit the subscribe button. Thank you for watching and enjoy the rest of your day. Thank you. Bye.